Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 6 of the condensed matter physics, okay, in which I'm going to discuss some questions related to crystal structure, and also I will discuss reciprocal lattice. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, okay guys, so I'm going to start. So I'll start with question of crystal structure. Okay. So the first question is find find the find the maximum radius. Find the maximum radius. Maximum radius of sphere. Of sphere. Maximum radius of sphere. Okay. That can be that that can be just fitted. Just fitted. That can be just fitted into the just fitted into the void between the body centered atom body centered atoms of BCC of BCC, base centered crystal. Okay, BCC. Okay, options are: option A is 0.155 R, option B is 0.144 R, option C is 0.199 R, option D is 0.431 R. Okay, so this is the question guys. So what you need to find the maximum radius of sphere. Okay, the radius of maximum radius of sphere that can be just fitted into the void between the body centered atoms of BCC. Okay, so that can be just fitted into the atoms between the body center, the void between the body centered atoms of BCC. Okay, I'll show you. So I'm going to solve it. Okay, so this is the crystal, BCC crystal. Okay, this is the BCC crystal. This is the BCC crystal guys. Okay, so this is the atom, center atom. Okay, which is at center, and this is like this one and this. Okay, so this can be fitted into this one guys. This is the sphere. Okay guys, this is not looking, but it's a sphere guys. Okay, like this. This is the body centered one. Okay, so between these atoms, right, between these, the radius of sphere. Okay, the maximum radius of sphere we need to find out. Okay, so this is the case, right? Now we can easily solve it. So this total distance is A, we know, right? And this is R, this is R, and this is the circle guys. It's a sphere. Okay, but it is not looking, but it's a sphere guys. Okay, and this is the Diameter of sphere means this radius is this is 2r, this distance is 2r, right? So from here, so this is the find the maximum radius of sphere that can be just fitted into the void between the body centered atom. Void means the that the empty space remained between these body centered atom, right? So this is the sphere. Okay, it's a sphere, guys. It is not looking, but it's a sphere. If you make a proper diagram, so it will be sphere. Okay, and this total distance is a, we know, right? And this is the diameter of the this sphere, right? And this is the radius. This is the radius of this. This is the radius of this sphere. So it means if from here, from figure, we can clearly say that a, this distance a is equal to r plus 2r plus r. R is the radius of that body centered atom, and the r capital R is the radius of that sphere, which can be just fitted into the void between the body centered atoms. Okay, so from here we can get value of r. So value of r is going to be very simple calculation, that is a by 2 minus r, right? R is the radius of those atoms, body centered atoms, right? So from body centered atom, we know this condition, guys, we know, right? 4r equal to root 3a. And for uh, for FCC, we know that is 4r equal to root 2a, right? And for SC, simple cubic, we know r equal to, my apology, that is a equal to 2r, right? These conditions you must know, right? Okay, if you don't know this, please note down. Okay, so now we'll use this. From here we can get the value of a. Value of a is going to be from here. Value of a is this one, 4 upon root 3, 4 upon root 3 r, 4 upon root 3 r, right? Now we'll put the value. So this is for BCC. Okay, for BCC, for BCC, for BCC. Okay, for BCC, this one. Okay, so from here what we can do, we can now we can put value of a in this equation, right? So value of, then r is going to be 4 by 3, 4 by 3 r value is from here. Okay, a by 2, my apologies. So this is going to be a by 2. A means 4 upon root 3 r upon 2 minus this one r minus r. So value of r is going to be, so this will 2, right? So this is going to be 2r upon 3 root 3 minus r. Okay, so from here this r will take common, so this is going to be 2 by root 3 minus r. This is the value of r. So this value is going to be, if we calculate r, we have taken common, means this is 1 minus 1, right? So now we can calculate it. The value of this is going to be, if we calculate, this is 0.155 0.155 r. Okay, so this is the answer, guys. So which option is matching, guys? Option 0.155 r, 0.155 r. Okay, in similar way, this question be asked like, find the maximum radius of sphere that can be just fitted into the void between the simple cubic atoms of simple cubic structure, or the void between uh, the that FCC centered FCC atoms of FCC crystal, right? So I'll solve for those two as well. Okay, the maximum radius for the maximum radius of sphere that can be fitted into the void of face centered atoms of FCC. Okay, so this is, we can I'm solving this for you as well. So anything can question, any one of the question can be asked. Okay, so for FCC, it is going to be like this. I'll make a figure first. this one. Okay, so FCC means like this. These are FCC atom. Okay, so this is the void for FCC. This is the void. Okay, this is the one. Okay, this is the radius. Okay, this is a circle which can be fitted between the void of FCC atoms. Okay, this one. So this distance we know, right? This is A. Total distance is A. So from here we can easily find out this one. This is R, and this is 2R, guys. Okay, this is a square that can be fitted between this, right? For FCC I'm talking about. So this is going to be from here R plus 2R, R plus 2R is going to be equal to A, right? For FCC we should know. For FCC, from here first let me get the value. So this is going to be, so value of this is 2R plus 2R is going to be A, and from here value of, and now since we know for FCC we know 4R equal to root 2A, right? So from here we can get value of A is going to be 4R upon root 2. Now we'll put the value. So this is going to be, I will put the value. So 2R, okay, we can write like this. This is going to be 2R. 2 capital R is going to be equal to A minus 2R, right? And A value I'll put here. So 4R upon root 2 minus 2R, and we'll solve it. So this value is going to be equal to, if we solve it, this value is going to be 0.414R, okay, 0.414R. This is the answer for it, guys. Okay, so very simple. This we need to know. So this is the void space, right, between the FCC atoms. Okay, so this is if you solve it, so this is going to be 0.414R. Okay, next for SC, third is for SC. If for SC crystal, if it is asked, then this is going to be like this. For SC crystal it is going to be like this. Okay, let me make a figure. This is the one for SC atoms, like this is, so these are the atoms, guys. Okay, these are the atoms, right? And this is the void between these atoms. So this is the sphere of maximum radius that can be fitted, right? So this is like this. Okay, this one. Okay, from here you can see, or we can write, we can make like this. This one. Okay, like this. This one, right? This is the one R, 2R and R, right? This is 2R, this is R, and this is R, right? Simple. So for that, from here, from the figure you can see 2R plus 2R, capital R, right? 2R plus 2R, that is equal to root 3A. Okay, root 3A. Now for SC crystal we know, since for SC crystal For SC crystal, this we know A equal to 2R, right? So in place of A, we'll write 2R. So this is going to be 2R plus 2 capital R equal to root 3 into 2R, right? So from here, value of R is going to be 2 will get cancelled. Value of R is going to be root 3 minus small r, and this value is going to be 0.731 r. Okay, so this is the maximum radius that can be fitted between the uh, simple cubic atoms of simple cubic crystal. Okay, so these three questions we have made now. Okay, so this type, so anyone can be asked. Okay, so it can be asked for BCC, FCC, or SC. Okay, well, next question, guys. Next question. Okay, next question is, okay, next question. This is also a good question, guys. Question number 2. Question number 2 is Zn has SCP structure. Okay, Zn has SCP. SCP structure means hexagonal closed pack structure. Okay, that's zinc we are talking about. The height of unit cell is the height of unit cell height of unit cell is 0.494 nanometer. Okay, that is the height of the unit cell. Okay, unit cell of the Zn. Okay, 4 nanometer, 0.494 nanometer. The nearest neighbor distance is 0.27 nanometer. Okay, the nearest neighbor distance is 0.27 nanometer, means that is nearest neighbor distance means the you can say nearest neighbor distance is that is constant A, right? That is the given. Now atomic weight is given, and atomic weight atomic weight is given, that is 65.37 gram. Okay, calculate volume of unit cell. Okay, calculate the volume of, for SCP. Okay, you need to find the volume of unit cell. Volume of unit cell. Okay, this is the question, guys. Okay, options are given. Option A is 8.3 into 10 to the power minus 29 meter cube. Okay, option B is 7.3 into 10 to the power minus 29 meter cube. Okay, and option C is 12 into 3 into 10 to the power minus 29 meter cube, and option D is 29.3 into 10 to the power minus 29 meter cube. Okay, so this is the these are the options. Very simple question. The question is Zn has SCP structure. Okay, Zn has SCP structure, and the height of the unit cell is given. Okay, it has that SCP structure and height is given. C is given, right? Height. This is 0.494 nanometer. The nearest neighbor distance is given, that is 0.27 nanometer. Nearest neighbor distance means that is the lattice constant A is given. Okay, atomic weight is given. Calculate the volume of unit cell. Okay, you should note down, guys. This is very important formula. Okay, and you should note down. Okay, the volume of unit cell. Volume of unit cell. Unit cell for SCP. Okay, for SCP. Very important. You need to directly note down it and you need to memorize it, guys. Okay, very important. So else there would be a lot of calculations. So this is volume of unit cell is 3 root 2 a cube. Okay, as we know, right, volume of unit cell for simple for cubic structure, that is a cube, right? Similarly, volume of unit cell for SCP is this, and this also, both you need to note down. Second, you know already. Okay? Volume of unit cell for that is a simple cubic, right? That is a cube. This unit a cube, or this is a cube, right? For cubical structure, I would say cubical, because BCC, FCC, everything will come, right? For cubical structure. So these two formula are important. This you already know. This you need to note down. Okay. So volume of unit cell for SCP. Volume of unit cell of that for hexagonal closed pack structure SCP is 3 root 2 a cube. Okay. Now if you know this formula, you can easily solve this question. Okay. So we have been given that this is we have been given a equal to given. We have been given this the nearest neighbor distance is this. Nearest neighbor distance means that is the lattice constant. Okay, a is given, that is 0.27 nanometer. Okay, a equal to this, you need to know nearest neighbor distance in SCP means the lattice constant a. Okay, 0.7 nanometer. So this is going to be 0.27 into 0.27 0.27 into 10 to the power 10 to the power minus 9 meter. Okay, so this is lattice constant. Okay, this is the lattice constant which is given. Okay, so 0.27 into 10 to the power minus 9. Okay, this is the lattice constant given. Okay, so now we can easily find out. So this is going to be now the volume of SCP unit cell. Volume of unit cell is going to be, so this implies volume of unit cell. Volume of unit cell equal to 3 root 2 a cube, right? This one, 3 root 2 a cube. 3 root 2 a cube means 3 root 2 into 0.27 into 10 to the power minus 9 cube, right? We'll solve it, and this value is 8.3 into 10 to the power minus 29 meter cube. Okay, so this is the answer, guys. So which option is matching? Option A is matching, guys. Okay, so 8.3 into 10 to the power minus 29. Okay, next question, guys. Question number 3rd. Question number 3rd. Okay, question number 3 is if the molecular weight molecular 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 weight if the molecular weight of NaCl is 58.5 gram and density is given, that is 2.17 gram per centimeter cube, okay, gram per centimeter cube. Calculate the distance between adjacent atoms distance between adjacent atoms in NaCl. Okay, option A is 5.5 angstrom, option B is 2.7 angstrom, option C is 1.7 angstrom, and option D is 6.5 angstrom. Okay, so this is the question, guys. So question is, if the molecular weight of molecular weight is given, guys, that is 58.5 gram, and the density is given 2.17 gram per centimeter cube. Calculate the distance between adjacent atoms in NaCl. Okay, so the distance between adjacent atoms in NaCl. Okay, that distance we need to find out. So I'll solve it for you. So for NaCl structure, we know, right? Rock salt we also call them. Okay, NaCl structure we know 2 RNA, 2 into radius of sodium and 2 into radius of chlorine equal to A. This is what we know, guys. You need to note down. Okay, I have already explained rock salt, NaCl salt, NaCl. Okay, structure. You can check my previous lectures of crystal structure. Okay, so this we know, right? So from here, RNA plus RCl is going to be A by 2, right? So RNA RCl means, right? The radius of, like, this is the crystal, right? This is RNA. This is Na structure. This is the radius of Na, right? This is the right. So this is the radius. This is the radius of NaCl, right? These are the radius. Distance between them we need to find out, right? So this is going to be A by 2. Okay, because this complete distance is this A by 2 from the center, A by 2, right? So what we need to do is, now this is the distance between two adjacent NaCl atom, right? RNA plus RCl, right? This one I'll show you. This is the radius, this is the one, right? These are touching, right? From this center to from this center, this distance, center to center, right? Now what? So now we have to find the value of A. We'll put the value of A in equation 1 and we'll get the adjacent distance between two atoms, right? Okay, so now we know we have a formula, right? We know, I have already explained that formula also. This is that we know, this is A is, or we can write A is, we know, N effective into molecular mass upon this one, density atomic density into Avogadro number Na to the power 1 by 3. This we know, right? This formula, very important formula. I have explained this in my previous class, right? So this is where A equal to this, and also rho equal to, we also get it, right? So value of A is this. Just we need to find the value of A and we need to put this in equation 1. We'll get the required answer. Okay, distance between two adjacent NaCl atoms, right? Well, so now A is going to be N effective. So for NaCl is a simple cubic crystal, right? N effective is 1 into M. N effective is no for NaCl, right? So for NaCl, effective number of atoms are 4, guys. My apology. This is for just simple cubic one. Okay. So for NaCl, this I have already explained. I have explained NaCl structure, so you can check it. So for NaCl, N effective equal to N effective equal to 4. Okay. So we'll put the value here. So this is going to be this one. 4 into molecular mass is given, right? 58.5 upon rho is given 2.17, right? Into Avogadro number we know is 6.022 into 10 to the power 23, right? To the power 1 by 3. Okay, so this value is coming 5.5 angstrom, guys. Okay, so from equation 1, from 1 Rna plus Rcl, distance between two adjacent atoms, right? This is going to be A by 2, that is 5.5 upon 2 angstrom, and this value is 2.7 angstrom. Okay, so which option is matching, guys? 2.7 angstrom. Let me check. Option D is the correct option, guys. Okay, simple one. Next question, guys. Next question is calculate the density of 100 plane. Okay, it's a planar density 100 plane in SC lattice. Okay, simple cubic lattice in SC lattice of lattice constant A equal to 2.5 angstrom. Okay, A equal to 2.5 angstrom, and options are: option A is 6.6 into 10 to the power 19, okay, per meter square. Option B is 2.6 into 10 to the power 19 per meter square, and option C is 3.6 into 10 to the power 19 per meter square. Okay, and option D is 1.6 into 10 to the power 29 per meter square. So this is the question, guys. Okay, calculate the density of 100 plane. Okay, 100 plane in the SC lattice of lattice constant A equal to this. Okay, so that we need to find planar density, and for SC we know planar density. For SC, rho is planar density rho is rho equal to 1 upon A square, right? So we'll just put the value 1 upon A square. A is given for this. For SC, for simple cubic of plane this. Okay, the density is 1 upon A square, means 1 upon 2.5 into 10 to the power minus 10 whole square angstrom, right? So this is going to be 1.6 into 10 to the power 19 per meter square. Okay, so which option is matching? Option D, 1.6 into 10 to the power 29. My apology, it's 29. It's 19. It's not 29, guys. We have made mistake. It's 19. It's 19. Yeah, these are 19. Okay, so this is the answer. So I have told you how to note down these values, right? I have explained in chart. I'll show you here. Like for one for 100 plane, for 110 plane, for 111 plane, right? This is SC, this is for BCC, and this is for FCC, right? This plane. So what we need to do? We need to write 1 upon a square, 1 upon root 2a square, 1 upon root 3a square. Simply we have tried the same thing. 1 upon a square, 1 upon root 2a square, and 1 upon root 3a square. Again we have to write 1 upon a square, 1 upon root 2a square, 1 upon root 2a square. And this is what we need to do is, this is L, means from here L. Here we have to change the value. So it is going to be 2 upon 2 root, 2 upon 2 root, and this is 4 upon 2 root, right? So these are the values. This by chart. I have explained this chart. You can check my previous lecture. Okay. So that's why I've directly written 1 upon a square, right? And the lattice constant is given, and put the value, and this is the answer, guys. Okay. Well, so this is this question. Next question we are going to solve. Just it's taking time. Next question. Next question is, these are very good questions, guys. Okay. Next question is, sodium transforms